Okay, we're going to talk here about the algebra of rational expressions, and it's going to be very similar to the algebra of ordinary fractions. The only difference is that we're going to be using polynomials and variables in these expressions. And our first algebraic identity is one that shows us how to cancel. If I have a times c over b times c, where a, b, and c are polynomials, then that's equal to a over b, except where c is equal to 0. And we'll see what the difference is when c equals 0. So suppose I want to simplify this rational expression. Well, the thing to do with rational expressions is to move towards factorization rather than expansion. So to simplify this, I want to see if anything cancels. And so I want to factorize this. I recognize this as a squared minus b squared, so that's going to be x minus 3 by x plus 3. And then I'm going to try to factor the denominator here. The leading coefficient is 1, so I should get x plus something times x plus something, and the product of the constant parts here should be 3. So I'm going to try the factors of 3, the integer factors 3 and 1, and see what happens. Now this is plus or minus 3, and this is plus or minus 1, and I notice that both should have the same sign here, because their product is plus 3, and they should add to negative 4, so they're both going to be negative, and that works. Now this is my c here, x minus 3. It's common to both numerator and denominator. This is a and this is b. And what we're saying here with this rule is that I can cancel the x minus 3. So this is a over b, x plus 3 over x minus 1, as long as x is not equal to 3. And you'll see the difference here when x is 3. When x is 3, this is defined. So the domain of the expression on the right here is all x except for x equals 1. And the domain of the expression on the left is all x except x equals 1 and x equals 3. Because if x equals 3 here, we have 0 over 0, which is an indeterminate quantity. It's not defined, doesn't make sense. So this expression on the left equals this expression on the right everywhere except when x equals 3. And that observation will be very important for us when we're calculating limits in the first few lectures of Calculus 1. We have other algebraic manipulations which we can generalize to polynomials. The next one is when we're multiplying two fractions, a over b times c over d, we multiply the numerators and we multiply the denominators. And the same holds true with rational expressions. So here, if we want to multiply these two rational expressions, we multiply numerators and denominators. Now I would also like to simplify these, and I'm going to do that by factoring. As I mentioned before, the way to go is to factor polynomials when multiplying and manipulating them. Now, I believe this should be an x squared here, Otherwise, it doesn't really make sense. Well, it does, but it should be minus 4x. And it's not going to be terribly interesting, but I'm going to put a square there because I did intend for that to be a square initially. Okay, so I'm going to factor everything I can factor here. I have x minus 3 there, and this is a squared minus b squared, so that's x minus 3 times x plus 3, and this one should be x plus something times x plus something, unless it's irreducible, and we'll see how to identify those pretty soon. Okay, the factors of this, the product should be 1, so I'm going to try 1 times 1 here, and they should add to negative 2, so in fact I'm going to make it negative 1 times negative 1. And here, for this one, we should have the product of the factors is 4. I'm going to give 4 and 1 a shot because they should add to negative 5, and I can make negative 4 and negative 1 add to negative 5. So those are my factors, and now we just multiply numerator and denominator. So we have x minus 1 squared times x minus 3 times x plus 3 over x minus 3 times x minus 4 times x minus 1. Now I have some cancellation. X minus 3 will cancel with that x minus 3, and this x minus 1 will cancel with one of those x minus 1's. So I have x minus 1 times x plus 3 over x minus 4. Now, as I mentioned before, this expression equals this expression only if x is not equal to 1 and x is not equal to 3. At the points x equals 1 and x equals 3, the expression on the right is defined, so these 2 points are in its domain, but they are not in the domain of the original expression, this expression on the left. Now to divide rational expressions, we do what we do with fractions. In the rational numbers, a over b divided by c over d, we invert this fraction and multiply. So it's a over b times d over c. So let's try x minus 3 over x squared minus 4 divided by x squared minus 9 over x squared minus 7x plus 12. It's 12, not 2. Okay, first of all I'm going to invert this fraction, so that's x minus 3 over x squared minus 4 times x squared minus 7x plus 12 over x squared minus 9. And now, as I mentioned before, the way to go is to factor everything in sight and see if we can cancel anything. So we have x minus 3, and of course I multiply the numerators here, and I'm going to try to find the factors of x squared minus 7x plus 12. And here I have x squared minus 4, which is x minus 2 times x plus 2. That's the difference of 2 squares again. And this is the difference of 2 squares. That's x minus 3 times x plus 3. Now I have to find the factors of x squared minus 7x plus 12. And I need two numbers which, when I multiply them, they give me 12, and when I add them, they give me -7. So I have to search through the factors of 12. 6 times 2, that's not going to work, because 6 plus 2 is 8. 3 times 4 will probably do the trick. So when I multiply, they both must have the same sign, because I get a plus when I multiply, and that sign should be negative, so that when I add, I get -7. Now I can cancel. I have that x minus 3 will cancel with one of the x minus 3's there. And that's about it. That's all that I can cancel here. And this is x minus 3 times x minus 4 all over x minus 2 times x plus 2 times x plus 3. And I'm not going to expand here because it's much easier to understand what's going on with rational expressions when you have the factors of the polynomials. This is true as long as we have equality here if x is not equal to 3. When x is 3, 3 is not in the domain of this one, but 3 is in the domain of the expression on the right-hand side. Of course, 2 and -2 and -3 are not in the domain of this or this, but 3 is in the domain of this one, and it's not in the domain of the one on the left. But these two are identical everywhere except when x equals 3.